Hello students, those who didn't subscribe this channel, kindly subscribe. If you need any sample paper or question papers, please comment in the comment box. I will upload the question papers and sample papers for your practice. So this is the continuity to the previous video. Here we are going to discuss 3 more questions from the sample paper given by the CBSE. Question number 25. Draw the energy band diagram for p-type semiconductor at temperature 0 Kelvin and room temperature. In the given diagram, considering an ideal diode, in which condition will the bulb glow? When the switch is open or when the switch is closed? Justify your answer. While coming to the first part, the energy band diagram at T is equal to 0 Kelvin. Here it is a conduction band. This is a valency band. At temperature is equal to 0 Kelvin, then conduction band is empty. There won't be any free electrons in conduction band, and valency band contains valency electrons. It may contains few holes also. Why means it is p-type semiconductor, but everything is within valency band. At the room temperature, that means temperature T is equal to nearly 300 Kelvin. That is at room temperature. This conduction band will have few electrons, and the conduction valency band contains holes and electrons, but number of holes in valency band is very larger with compared to number of electrons in conduction band. And there is an energy level just above valency band, which is called acceptor energy level, E sub A. This gap is nearly 0.01 to 0.05 electron volt. This is for the 1 and 2. Coming to the second part. In the given diagram, considering an ideal diode, in which condition will the bulb glow? So the bulb will glow only if the current is passing through the bulb. That means when the switch is open, then only the current will pass through the bulb will glow. That means the switch should be in open. If it is closed, then current won't pass through the bulb, current will pass through only the diode. Why means in ideal condition, it offers 0 resistance. So no current will pass through the bulb. So justification means we can write this. When the switch is open, the current will pass through the bulb will glow. When the switch is closed, because of ideal diode, resistance is 0 here for ideal diode, then most of the current will pass through the diode, then bulb won't glow. Coming to 26th. A boy is holding a smooth, hollow and non-conducting pipe vertically with a charged spherical ball of mass 10 gram carrying the charge of 10 millicoulomb inside it, which is free to move along the axis of the pipe. The boy is moving the pipe from east to west direction in the presence of magnetic field 2 Tesla. With what minimum velocity should the boy move the pipe so that the ball does not move along the axis? Also determine the direction of the magnetic field. Well, coming to the solution. Here, the ball should not move means the ball is in equilibrium. And considering the mass of the ball is 10 gram, that is also nothing but 1 into or 10 into 10 power minus 3 kilogram, and charge Q is 10 millicoulomb, that is 10 into 10 power minus 3 coulomb, and the magnetic field given is 2 Tesla. It is from east to west direction. Sorry, boy is moving from east to west direction. The magnetic field is 2 Tesla. While coming to equilibrium condition, because the ball is in equilibrium, magnetic force will be is equal to gravitational force. So magnetic force is QVB sin theta, the force acting on the ball. So we can imagine this is the pipe, this is the ball, and it is moving with certain velocity. That is a minimum velocity. So here weight is acting downward direction and magnetic force is acting upward direction. So from this, V is equal to mg divided by qb sin theta. For V minimum, sin theta should be is equal to 1. That is, theta should be 90 degrees. Mg divided by qb. That is, mass is 10 into 10 power minus 3. G, you can take 9.8 divided by 10 into 10 power minus 3, that is the charge. B value 2. If we simplify, we'll get 4.9 meters per second. With this speed, the boy has to move to make the bob or body to be in equilibrium. While coming to the direction, from Fleming's left hand rule, we can find out that the direction of the magnetic field will be along north to south direction. While coming to one more problem, a light ray entering a right angled prism undergoes refraction at the face AC as shown in figure. What is the refractive index of the material of the prism? Here, the angle of incidence will be 45 degrees and it is traveling along the interface. So, angle of refraction will be 90 degrees. If we are applying Snell's law, that is, refractive index of the prism, suppose say mu into sine of 45 degrees is equal to refractive index of the air into sine 90 degrees. So mu into 1 by root 2 is equal to 1 into 1. So mu is equal to root 2. This is the refractive index of the prism. Now, if the side AC above the prism is now surrounded by a liquid of refractive index 2 by root 3 as shown in figure, determine if the light ray continues to gauge along the interface AC or undergoes total internal reflection or undergoes refraction into the liquid. Which case is possible? We need to check. Undergoes refraction. This is the answer. How to justify it? That means here automatically the critical angle increases and angle of incidence here 45 degrees. We have to determine critical angle. If the angle of incidence is more than critical angle, then only it will undergo total internal reflection. Otherwise, it will undergo just refraction. Now, to find this, we can write sine of critical angle is equal to 1 by refractive index. This refractive index is nothing but refractive index of glass with respect to liquid. That is equal to refractive index of glass, refractive index of the liquid. So refractive index of the liquid is 2 by root 3 divided by root 3, and theta c is equal to, critical angle is equal to sine inverse of root 2 divided by root 3. This value is given here. Sine inverse of root 2 divided by root 3 is 54.6. That means 54.6 degrees. As angle of incidence, that is 45 degrees, is smaller than critical angle 54.6, the ray undergoes refraction. Into the liquid. That's why it is the answer. Next one. Draw the ray diagram to represent the path followed by the incident ray with corresponding angles. Here, the diagram can be shown like this. This is B, A, C, and 45 degrees. The ray is incident. On AB it is normal, but on AC angle of incidence is 45 degrees, and here liquid is there. Then definitely it will travel like this. It is angle of refraction. So what is the value of angle of refraction here? The refractive index of the glass into sine of 45 degrees is equal to the refractive index of the liquid into sine R. Refractive index of the glass, we got root 2 into 1 by root 2 it is. Refractive index of the liquid is given as 2 by root 3. Into sine R. So from this, 1 is equal to 2 by root 3 sine R. Sine R is equal to root 3 by 2. So that is nothing but R is equal to 60 degrees. This R value will be 60 degrees. State Gauss theorem in electrostatics. Using this theorem, derive an expression for electric field due to an infinitely long straight wire of linear charge density lambda. So for this one already I did the video in electrostatics. Kindly refer this in electrostatics playlist, and define electric flux and write its SI unit. Use Gauss's law to obtain an expression for the electric field due to uniformly charged infinite plane sheet. This is also in electrostatics playlist. Once you can refer. Further, if you require anything, so comment in comment box. Then I will try to upload. Thank you.